What's up, everybody? This is Eddie, and we are coming at you live from FlexArm's beautiful facility right here in Wapak, Ohio for yet another amazing demonstration with our good friends at Kyocera as well as Technics. We're going to be doing some face milling as well as some magnetic fixturing, but more on that here soon. Before we get started, on this side of the screen, you'll notice there is a comment section. Now, with this being a live and interactive stream, we not only encourage, but we anticipate each and every one of you to leave any questions or comments that you may have, pop them right there in that chat section, and you never know, we may be able to pull that bad boy up and answer those in real time. And another reason why that chat box is so relevant is today, our good friends at Kyocera are kind enough, we're gonna be having a giveaway of a Kyocera MFH Raptor tooling package. And the way to enter is all you gotta do is comment on that section, hashtag FlexCNC, as you noticed, flips it right up here, hashtag FlexCNC, you can enter yourself for a chance to win, and we'll be picking one lucky winner at the end of the stream. So also, before we get started, you'll notice on this section of the screen is a subscribe button. Make sure you hit that subscribe button, you hit that bell to turn on the notifications so we can keep you in the loop with all the amazing content we'll be releasing. And last but certainly not least, give us a huge thumbs up. So here we got a couple of all-stars with us today. So representing our good friends over at Technics, I got my man Brian. Brian, how you doing today, man?
Oh, dude, it couldn't be any better, man. If I was any better, my name would be Eddie.
Oh, my man. There we go. He's ready to go, man. So, that's amazing. We appreciate it. So, for those who may not be as familiar with Technics, or at least yourself, tell us a little bit about you and then Technics in general, man. Give us a good word.
Yeah, well, thank you. Viewers, my name is Brian Haskell. I'm the sales manager here at Technics Tool Group. For all of you that, like you said, are unfamiliar with us, we like to say we are the full gamut from the spindle to the workpiece. Everything from your tool holders to the collets to the way to hold it, which we're going to see today in our magnetic work coring, to right angle heads. So we have everything under the sun you would need to tool up and keep your machine running to its top performance.
There you go. No, I love it, man. And I've got some pretty interesting feedback on the magnetic fixturing. Got some people that are worried, man. So you ready to make some believers today?
I sure am. Let's see if we can't stall that spindle.
I like to hear it, man. Spoken like a gangster. I dig it. So the awesomeness doesn't stop there. Also from our good friends over at Kyocera, I got my man Elliot and Matt. How you gentlemen doing today?
Doing real good. Thanks for the intro. Like you said, I'm Elliot. Happy to be here with you guys today. Looking forward to run some tools really quick.
There we go. We're gonna make some chips. So Matt, I know you're a veteran of some of these live streams, so same question that I asked for Technics. Can you tell us a little bit about your line, what you're doing, and what Kyocera's up to?
Matt Newman. I'm an engineer with Kyocera here at our Wapakoneta facility. That's where we build all of our steel bodies, so milling cutters, drills, turning tools, boring bars, all that type of tooling. So my role is special tools and applications. So.
There we go. We got the trifecta of awesomeness. We're going to have some magnetic fixturing, some amazing tooling from Kyocera, and all on this beautiful machine right behind me. So I know you guys didn't join us to listen to me talk today, so I'm going to turn it over to our in-house CNC specialist, Aaron. Man, what's a good word? What's going on today? What are we going to see?
So like we talked about earlier, we're going to do some face milling today. We do have two different styles that we're going to showcase here. For the first demo we're going to do is we're going to run a 2-inch MFH, which is their high feed cutter, and we're going to take half of the block, face it down, and then the other half of the block we have for a 2-inch MEW cutter, which is more of their standard face mill, and we'll face the other half of the block, kind of showcase the differences between the two, and then after that we got some really cool footage of the 4-inch MFH, so it'll be an exciting demo.
There we go. Ready to get started, my man?
Yeah, let's do it.
All right, while he's getting that rock, and obviously for my Kyocera experts on the line, so we got a 2-inch MFH. Tell us a little bit about that. I don't know what that means, as maybe some of the viewers are pretty intrigued as well, so give us the insight on it.
Sure. So the whole philosophy with a feed mill, high feed mill, is that you're going to take a much lower depth of cut than you would with a standard cutter, but you take a much higher feed rate. So what you're looking at is super high feed rates and super high movement. Up until 20 years ago, this technology didn't even exist, and we've been working on it since then to really perfect this stuff. So what you'll see here, we're feeding across this workpiece at really high feed rates. We're getting the metal removal rate up really high. The way that this is done is that these inserts are actually set at a 15-degree lead. Whereas the next tool that we're going to be looking at is the 90-degree cutter that you can cut 90-degree shoulders with. This is actually a 15-degree lead, and what that does is it takes all the force from the cut and pulls it up directly towards the spindle. So instead of the cutter wanting to lean away from the workpiece while you're putting it in there, it actually directs the force straight up into the spindle and gives it a little bit more stability. This enables the high feed rate. Our feed mills are all 15-degree lead, and that's what that accomplishes for you. You can cut 90-degree shoulders with this tool, but it'll just be in a little bit of a step down, a short step down, a little bit of a time. What you'll notice is these chips coming off here, spraying out really, really nicely. These produce an excellent looking chip, keeps all the heat into the chip, and it sprays it away from the workpiece. So here we got one coming down right now. What you'll notice here with the feed mill is that it is truly a roughing tool. It's going to leave a little bit of a rougher surface finish, a little bit of a scallop finish on the sidewall. But the point of these tools is, number one, to get the material off as fast as possible. In doing
So
this
that is
tool,
go ahead.
And with a really light feed rate, or with a really heavy chip and a really heavy feed rate, what you're going to do there is take all the feed and put it straight into the chip. This is the 90-degree MEW.
So the MEW cutter is a more of a traditional style face mill or end mill that people are used to. And as you can see already, that also going to leave you a 90-degree wall, but you're going to be running traditional type feed rates with this. 5 or 6 thousandths per tooth on the feed rate instead of 30 or 40 thousandths tip load on the MFH high feed cutter.
No, very interesting. So while this thing is plugging away, one question, I know we're running a 2-inch MFH and a 2-inch MEW. So why does that MFH feed a little bit faster than we're noticing on this other tool? I'm curious.
Yeah, the MFH is at a much lighter depth of cut. And also, you're not really looking at great surface finish with the MFH. But if you watch this tool while it's running, you see that nice, beautiful mirror-like surface finish it leaves behind. The MFH will never leave a surface finish just that nice. However, you get it done probably much faster. So there's a little something for every application here.
Okay, looks like we just finished up on that second pass there. See if we can get a look at a finished part here in a second. Let me go grab our close-up cam, we'll check it out.
There's the footage of the finish there. The finish on the left is the MFH, and the finish there on the right, more of that mirror finish, is that MEW cutter. And just to kind of talk real quick on the feeds and speeds, the MFH, we're running at 1146 RPM, 330 inches per minute. So like they were talking, very quick, very fast metal removal rate. And then the MEW cutter, same RPM, 1146 at 27 inches per minute.
No, very good stuff. Obviously just rocking and rolling through this, doing some amazing finishes here. So I got a question, gentlemen. Obviously both of these are incredible tools. So in what circumstances would you choose one over the other?
It's going to depend on your customer's part. If they have a lot of material to take off, you're going to start with that MFH cutter and just get that material off, and then you can come in and finish with the MEW. Or if if your part doesn't have a lot of material on it, if it's a near net shape, a casting or something with only a small amount of material to take off, then you want to look at the MEW. So just depends on the operations that the customer needs.
No, yeah, clearly, obviously two efficient tools here. So with that, before we move on to the 4-inch, which I'm super excited about, is there anything else that anyone watching needs to know about either of these amazing tools?
Hey, Eddie, just a side note too, those tools are also through Coolant. Most of the time you're going to be running dry, but if the need arises, depending on the material you're cutting, they are through tool coolant capable. So.
No, solid point,
Well,
solid
and
point.
something just to add on that, Eddie, sorry. With it being through spindle coolant, I know something, applications that I've done before, instead of running coolant, if we were doing a pocket with a smaller diameter, I was actually able to run through spindle air. And shooting that air through the tool really helps get the chips up out of the way so we're not recutting chips. And so just a little side note to add to what Matt was saying.
There you go, coming from the machinist himself. I like it. That's great feedback. So obviously we were able to see two amazing tools. What's next, man?
Next, we got the 4-inch MFH. And I'll touch base on the feeds and speeds real quick. So we're going to run it at 575 RPM at a little over 200 inches per minute. Now, I don't know if we had any sound issues with that MEW cutter, but we got some really awesome B-roll footage of this. We didn't want to run it live just so we didn't have any audio issues. We wanted to make sure that we could hear our friends over at Kyocera. So we're going to run that guy right there. So Matt, Elliott, take it away.
All right, going to run this big 4-inch now. Going back to what we were just talking about right there. Speaking about the coolant, for instance, when you're running, especially steel material, with a high feed mill, you're almost always going to get much better tool life running dry rather than wet. Reason for that is as the inserts are entering the material and exiting the material, there's a lot of heat being generated there. So the tip of the insert, where it's contacting the parent material, heats up really, really quickly. When it comes out of the cut and you're using coolant, the coolant sprays onto it and it cools down really quickly. And that happening over and over and over again, just like dropping a hot glass bowl into a sink full of cold water, that creates a thermal shock on the insert. So running without coolant and dry is usually the way to go in roughing applications, not just with the MFH Raptor and feed mills, but also with the 90-degree cutters as well.
No, very solid, and one of the more exciting parts as well, aside from the tooling, is we're noticing the fixturing there. So obviously you can look at this bad boy, look at this hog right here, just massive, but it's not being held down by just anything. We have some special Technics magnetic plate there. So Brian, tell us the good and the bad and the awesome about this fixturing we're talking about, man.
Yeah, so what you're seeing there is our electro-permanent line. So we call them, it's an EEPM 6100, which is a 24-inch by 40-inch table magnet. That magnet itself is going to give you a little over 86,000 pounds of hold-down pressure on that part. So when I said earlier, let's stall that spindle, at an 18 horsepower spindle, you're going to stall that spindle out before that part's going to move. And as you see there, Aaron's using some actual positive stops there, so you can push an end mill, or in this case a face mill, as fast as hard as you want. And a lot of people's concerns are chips. So once this is activated, where's my chips going to go? Well, typically your chips are going to be evacuated and got away from your workpiece by either, like you were saying, air or coolant. And we'll be able to activate and get those all out of the way, and then you just need the power to activate and deactivate the magnet. You don't need to be hooked up constantly, so that really helps you be able to use shuttle systems and to get that table in and out of the machine very quickly as well.
No, it looks absolutely solid. And Isaac, if you wouldn't mind, can you pull up the B-roll of the face mill running over that, just so we can see how sturdy and strong that base plate is? And maybe, Brian, you could talk a little bit about what exactly we're seeing here. I mean, look, this thing's not moving. It's not going anywhere, right?
Oh, yeah. So what's going to help, too, is since we're completely supported underneath that with all those induction blocks you see, it's really going to help us with vibrations, and also with any, you can create as much tool force as you need with that, and we're not going to get it to move. We also offer an ability to do a spring pull. The spring pull is going to get away from the shimming. So anytime you have an inch or inch piece of plate, whenever you do magnetize that, if you do not have spring pulls, it will pull the plate flat, which will allow you to get a part parallel but not truly flat. So in this instance, we would just put a spring pull. It's got about 10 millimeters of float. You get your machinist point of 3. Everything else, you put floating blocks on there, and we can truly get a part flat that way. You can throw all your shimming tools out of that Kennedy toolbox you got floating around.
No, it looks good, and as you can see, it had such a positive impact on the process itself, and even a plate that large, I mean, that sucker's going nowhere, and we put a 4-inch face mill, and it took it right to the dome, for lack of a better term, you know. So with that, what other type of what other type of cool magnetic fixturing options do you have over there at Technics that would be either similar to this or ones that are really popular in your world?
Yeah, so we have another series called our ECB line. So most people are very familiar with a lifting magnet. So what we're doing is we're taking that technology, instead of activating the magnet to lift the part, we're going to flip it over and clamp it down the table. Now we pretty much have a lifting magnet upside down that we're going to be activating it manually to hold down. We have 4 different sizes. We're going to start with a single magnet of about 1,650 foot-pounds of hold-down power, all the way up to about 4,620 with one magnet. Those are very usable for the guys that have a handful of manual mills out there that just want a quick way to hold a part, to drill some holes or do some tapping. They're very, very universal, and we sell those quite a bit as well. So that's another good line that we see job shops and even getting into the production work field, that they can use those and utilize those.
No, seriously, I mean, the video is proof in itself, man. So hopefully, I'm pretty confident we made some believers today, so, or even solidified those who do. So thank you again for that feedback. And then kind of talk a little bit about the face mill. So really, what makes this specific tool stand out as opposed to maybe, you know, the 2-inch or some other tools that you guys have over there at Kyocera?
Well, this particular one thing that you'll notice about our geometry on the side of the insert is we have a convex cutting edge. You can see there on the side of the insert that the insert almost feathers into the cut. So what you'll notice versus our competitors, and you know, there is a lot of great tools out there, but what you'll notice is that ours sounds much, much better entering and exiting the cut, which is actually when the cutter is under the most stress and the carbide is under the most stress. We have a full lineup of grades for you know, all your material categories, everywhere from steel and stainless, non-ferrous, and you know, a couple different chip breaker options, a whole bunch of different sizes too. So the MFH Raptor series goes all the way down to 3/8 of an inch in a Raptor Micro, up to 6-inch in a 14 millimeter IC standard MFH Raptor, and even larger than that with special tools. So you know, we have something for everybody, and really for job shop environments. This is a tool that everybody can have in their shop, and it could do something great for your productivity.
Yeah, on that MFH cutter, also the one advantage of it is you can do pretty much any type of machining with it. You can do ramping, you can do helical milling, you can do the face milling, you can do plunge cuts. So you can do just about any type of milling that you need to get done with that MFH cutter.
Very nice, very nice.
It has all the moves in one package.
No, I like it, I like it. So hey, what I like even more is we got our good friends over at Metro Manufacturing with our first question. So thanks for pulling that up, Isaac. Now the question is, what was the spindle load on those? So would you guys be able to give us a little bit of insight on that?
That might be a better question for Aaron. I didn't see what the spindle load was on the control there when he was running it.
Well, because the exact number I didn't see, I would have to go back and rerun it to get those numbers. But you know, just talking about the style of the insert and the fact that it's a very shallow cut, the spindle load is very minimal when you're using these kinds of cutters. So you know, with this machine being an 18 horsepower machine, the fact that we are taking a much shallower cut, it really helps on our spindle load.
Yeah, very good, very good. Isaac, do we have any other general? Go ahead, sorry, please.
We've run these tools on BT30 machines, which if you've seen a BT30 machine, very, very small spindle taper connection, all the way up to Cat 60s. So feed mills are typically designed to keep that spindle load down.
No, very solid. No, thank you so much for that general question. So I got one more each for you know, the Technics side as well as the Kyocera. So let's start off with the 4-inch face mill, because it's obviously very intriguing. So what type of applications would we more than likely see that being used?
Boy, just about anything. You know, from what you're doing there, just milling off a plate. You know, the last time we ran a demo, we were making one of your FlexArm pieces with the smaller 2-inch MFH. So Yeah, just about anything that requires milling is something to look at.
Very good. And then same question for Brian over there at Technics. Where are we going to see these bad boys more often than not?
Like going back to what the gentleman just said before me, we're going to see it everywhere. They're great in a job shop setting, so where you're not going to know what you're going to do from day in to day out. That magnet's universal, especially if you're running a probe setup. You can throw that part on there any which way, touch it with the probe, it'll ordinate your program, you're ready to run. All the way to your manufacturing, to your production shops, where they can use that day in and day out and get the same repeatability, same end result with the same magnet, and that we see that quite a bit as well. So it's going to be a gamut across the board. Whoever has chips they're making, they can use our magnets.
No, I love it, man. There's some great things that have happened today. So as we have to double check, do we have any questions up on the board right now? Wonderful. So with that, don't forget, before we were done, make sure hashtag FlexCNC in that comment section for the chance to win the Kyocera MFH Raptor tooling package. And again, as we're wrapping things up for the Kyocera side, so for those who are looking for more information or want to just generally learn more or reach out and get more information, where are they supposed to be looking?
KyoceraPrecisionTools.com.
There you go. And then also same thing for Technics. Where am I going to get more information on these amazing magnetic fixturing pieces, my man?
Yeah, as you see in the bottom of the screen, TechnicsUSA.com, or feel free to call us up at 800-597-3921. Any of us lively personality guys would love to speak with any of you have any questions.
There you go. No, it's wonderful, and it's amazing. We got the trifecta of awesomeness today. We got a FlexCNC with some Kyocera face mills, all tied up and held down with some Technics magnetic fixturing. So this has been an amazing, amazing live stream. So we appreciate you three gentlemen on the call. Thank you so much to our good friends Elliot, Matt, and Brian. You guys are true industry experts, and we are so thankful. Thank you as well, Aaron, for being our in-house CNC specialist. So make sure you check out their information on the bottom of the page. Also, before you go, you hit that subscribe button, you hit that bell to turn on the notifications, and then last but certainly not least, give us a huge thumbs up. I'm Eddie. You all stay awesome, stay flexing, and we will see you next time.
Guys.